And then we have started with the periodic signals. What is periodic? What is not periodic? Even odd signals, combination of odd signals, even signals, integral derivative of odd signal, even signal, discrete time, even and odd signal, energy and power signals. What is a system we have seen last class? Example of systems we have seen. Example is LR circuit. Mathematical modeling of continuous system we have seen. Discrete time system also we have seen. Order of system we have seen. Interconnected systems we have seen. Feedback system we have seen. Causal anti-causal system we've seen. Linear nonlinear system we have seen. Invariant, time invariant and time variant systems we have seen. Now we are going to start today with stable and unstable systems. System is said to be bounded input, bounded output stable or BIBO stable if every bounded input results in bounded output. So that mod xt is less than equal to mx is less than infinity implies for all t, yt is less than equal to my less than infinity. That means it is called BIBO stable. A system is said to be bounded input, bounded output stable if and only if every bounded input results in bounded output. So if your input is bounded, your output must be bounded. So for all t, if xt is less than equal to mx, which is less than infinity, which is not infinity, then for all t, yt must be less than equal to my, which is less than infinity. So for example, let's say yn equal to minus yn equal, let's say yn equal to 1/3 of xn plus xn minus 2 minus 1 plus xn minus 2, then yn equal to 1/3 mod xn plus xn minus 1 plus xn minus 2, which is less than equal to mod 1/3 x mod xn plus mod xn minus 1 plus mod xn minus 2, which is less than equal to 1/3 mx plus mx plus mx, which is equal to mx. So this is a stable system. Got it? Yes.
Yes, sir.
Have you understood this? Other students, have you understood this?
Yes, sir.
Yes,
Your xn is actually bounded from above by mx. So mod xn is less than equal to mx. Mod xn minus 1 is less than equal to mx. Mod xn minus 2 is less than equal to mx. And from second line to third line it comes as because xn plus 1, because a mod 1/3 of mod a plus b plus c equal to is less than equal to 1/3 of mod a plus mod b plus mod c. Okay, the system represented by yt equal to axt is unstable. A is greater than 1. Reason, let us assume xt equal to yt, then every instant yt will keep on multiplying with a and hence it will not be bounded. Okay, yt equal to axt is unstable, a is greater than 1. Let us assume that xt equal to ut, then at every instant ut will keep on multiplying with a and hence it will be bounded. Is it clear?
yes, sir.
Okay. Static and dynamic system. A static system is a memoryless system. It has no storage devices. Its output signal depends on present values of the input signal. For example, it equal to 1 by r vt. A dynamic system possesses memory. It has a storage devices. A system is said to possess memory if its output signal depends on past values and future values of the input signal. For example, if there is an inductance 1 by L, then it equal to 1 by L minus n into plus t b tau d tau. Yn equal to xn plus xn minus 1. Depends on present value as well as previous value. So this is a dynamic system.
Sir, in that case, is dynamic systems always causal?
Always causal, right? Because causal means what? Causal means that it depends on previous values and present values. but not on the future values. Causal means it is previous values and present values.
Static systems only depend present values.
No, that static system and non-anti-causal systems are not same, right? Right? Static systems are also causal. Am I right?
Sir, could you static systems? Yes, it only depends on the input signal values, so it should be causal.
It is causal, right? It is
Yes.
causal. And dynamic systems are also causal. Okay. Example, is this a static system or by dynamic system?
V1, V2. V1 is the input signal. V2 is the output signal. So it's dynamic, sir, because past values also matter over here.
How?
Sir, because one run through the circuit gives one value of V1T which affects V2. Oh no, it's static, sir. Static, sir.
Why
Static, sir.
static? Why
So
static?
because only V1T is affecting V2T, right? Like only in one round only V1T is affecting. It's the present value.
No, but capacitor output also the voltage across the capacitor is V2T. That is dependent on the capacitor also, right?
Oh, okay. Capacitor is also storing. So it will be dynamic and then.
It will be dynamic system, right? Anybody else has any questions from this? Yes?
So what if in case multiple resistors or multiple capacitors are attached?
That
Then
will
will
be
it
dynamic.
depend upon the
That will be
okay.
dynamic also. Okay?
Okay, sir.
And static means no capacitor or no inductance is there. Capacitor static means it will be only R. Okay. Answer the above system. The above system is RC circuit. R is memoryless. C is memory device as it stores change because of which voltage across it cannot change immediately. Hence, given system is dynamic or memory system. C is memory device as it stores charge because of which voltage across it cannot change immediately. Hence, given system is dynamic or memory system. Invertible and inverse systems. If a system is inversible, it has inverse. If a system is invertible, it has an inverse system. So xt gives output yt to the inverse and gives output xt. For example, yt equal to 2xt. System is invertible, must have inverse. That is, for any xt, we must get the distinct output yt. Thus, the system must have an inverse xt equal to 1 by 2 yt equal to zt. Is it clear? Invertible system. Invertible system means a system that produces an output given through the inverse system will produce the input again. For example, yt equal to 2xt. Is it okay?
So
Okay. LTI systems are completely characterized by its unit sample response. The output of any LTI system is a convolution of the input signal with the unit impulse response. That is, yn equal to xn star hn equal to sum k equal to minus infinity to plus infinity x k hn minus k. That is called a convolution. Xn star hn. It is not product. It is called convolution. LTI
could you explain this again, sir? I didn't get it, sir.
LTI systems are completely characterized by its unit simple response. So the output of any LTI system is a convolution of input signal with the unit impulse response. Hx is the unit impulse, and xn is the input signal. So their convolution is yn.
Okay, sir. So what is the full form of LTI, sir?
I don't know. I have to see that. Okay, properties of convolution. Commutative property. Convolution means this particular symbol. Xk hk into hk hn minus k sum k equal to minus infinity to plus infinity or xk hn minus k dk, sum k equal dk, yes, sum minus infinity to plus infinity, integration minus infinity to plus infinity. So properties of convolution, commutative property, is it correct?
Yes, sir. Yes, sir.
Why?
Sir, because sir, we are it's the since convolution is basically the summation of xk and h n minus k for the example that you gave. So multiplication is commutative. So in that case, the reverse will also be the same, sir.
You can replace n minus k by,
Yes, sir.
you can
X
replace the
n
variables,
yes, sir.
change of variables, right?
Yes, sir.
So n minus m and m, and then the sum will remain same. The sum m will remain the same, minus infinity to plus infinity. Am I right?
Yes, sir.
Okay. Distributive property xn convolution h1n plus h2n equal to this. This is obviously correct, right?
Yes, sir.
By definition, this is true. Associative property xn into h1n into xn convolution h1n convolution h2n equal to xn convolution h1n into convolution of h2n equal to xn convolution of h2n convolution of h1n. Is this correct?
Yes, sir. Yes, sir.
Why?
Sir, because of commutative property itself, sir, so you can like divide it into two systems and then go forward with it, sir. Subsystems, basically.
That's right. Commutative property gives rise to h1n and h2n can be commuted, and then you can do that. Useful properties of DTI LTI system. LTI means what? LTI means I don't
So
know actually.
convolution of input with unit impulse.
Yes, convolution of input with unit. Useful properties of DTI LTI system. Causality Hn equal to 0, stability sum k equal to minus infinity to plus infinity, hk is less than minus infinity, bounded input implies and implied by bounded output. Xn is less than equal to x max is less than infinity, yn equal to is less than x max is less than infinity. Did you understand? Causality for the DTL system,
Yes, sir.
because if it is less than n, then no values will remain. Unit impulse means it will come at n equal to 0. Other values will be cancelled, right?
Yes, sir.
And stability means some k equal to minus infinity to plus infinity, hk is less than infinity. Why is that true?
So yes, sir, because it's discrete, sir. So you can just add them, sir. It will remain. It will not go to infinity, sir, because it has a crest and a trough also. So that will cancel itself out.
Right. And bounded input to bounded output.
Bounded input. So same reason, sir. Because since if there is an amplitude, sir, it will be less than a certain value.
Right. So that's actually there in this system, this slide, all of this. Now, do you have any questions? Yes? Anybody has any question from this slide? Whatever I have covered, signal systems, whatever I have covered. So should I move on to next slide?
Yes, sir.
Yes, sir.
I'm not finding the slide actually. Just wait for some time. I'm looking for it. Okay, let's stop today. Okay, I'm not finding the slide. I'll find the slide and start next class. Okay. Do you have any questions
Okay,
from?
sir.
Do you have any questions from these slides?
Sir, not yet, sir.
You have got the slides.
Yes, sir. Yes, sir. We got the slides, sir. Sankita sent them to us yesterday.
Everybody got it.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir. Yes, sir.
Okay, okay. So next class is next Wednesday from 4:30. Okay.
Yes, sir.
So I will start with Laplace transform from that class. And when is your exam, by the way? First exam?
Yeah,
Sir,
20
end of
September.
February, sir.
20th February.
No, sir, 20th February, I think.
20th February.
Yes, sir.
20th February that week, right?
Sir,
Yes,
22
sir,
to
that
27, sir. 22 to 27.
22 to 27 is first class test.
Yes, sir.
Yes.
CA.
CA1.
Yes, sir.
Sir.
15
Okay,
marks.
then I think I will be finishing Laplace transform by then also. So Laplace transform and this chapter will be your syllabus. Okay?
Okay, sir.
Okay,
Yes,
okay.
sir.
Then I am leaving. You got the slides, you read it, and